600 plus houses were declared unsafe. Thousands of the families were ordered to evacuate their homes in 15 minutes. What we witnessed here was Joshimat in January 2023, the town that sank overnight. Or did it? The signals showed that the ground had moved over 9 centimeters over the past 7 months. There were signals, but no one was listening. That's the invisible risk problem we are dealing with. Today, we measure everything. We measure rainfall, we measure earthquakes, but we do not operationalize ground deformation intelligence. The research already shows that the physics works. There is detection, but there is no decision. That's the missing layer we are here with. Because infrastructure owners, they don't need research papers, they don't need maps. What they need is they need risk tiers, they need decision triggers, they need the middleware which is absent right now. They need something that translates deformation physics into actionable financial intelligence. That's where we come in. We are VIGIL-Earth, the risk intelligence layer. VIGIL-Earth ingests freely available satellite radar data, filters the atmospheric noise, models the acceleration trends, and outputs the structured risk tiers as green, yellow, and red. Now you may ask, how do we prevent false positive? We understand that Alps are different from Himalayas, but the underlying physics for ground deformation is same for both. We set different controls, we set different thresholds for different geographical areas. But where we draw a line is we explicitly define predictable or non-predictable categories. What cannot be predicted, we do not claim to predict. We do not claim to predict flash floods or instant rockfall. What we monitor is deformation-driven slope instability. We define limits and thus we increase credibility. By shifting detection earlier, we aim to increase lead time, reduce shock, and improve infrastructure planning, which directly aligns with SDG 11 and SDG 9.
Our primary customers are infrastructure operators and insurance institutions. We operate on a subscription-based model per monitored asset zone. Each zone is priced at approximately 40 to 80 lakhs annually. Our operational costs per zone is around 20 to 30 lakhs, which includes satellite data processing, cloud compute, storage, and analytics infrastructure. This allows us to maintain a healthy gross margin of upwards of 60% while delivering measurable financial value. For insurers and infrastructure authorities, even a marginal reduction in loss volatility justifies this subscription cost. If a corridor, say, carries 100 crore in exposure, reducing failure probability by even a few percentage points translates into crores saved. We are not selling data, we are improving underwriting precision and strengthening capital confidence. India alone has thousands of climate-exposed infrastructure corridors, mountain highways, dams, bridges, and urban slopes. This model scales geographically, not virally. Each new region adds structured monitoring capacity without exponential cost increase. This is our operational prototype. It tracks deformation trends, velocity modeling, and risk classification. This architecture is functional and the prototype is operational as of date. Why now? Well, because public satellite data already exists. Cloud processing is accessible, climate volatility is rising. The missing piece is structured translation, converting deformation physics into decision-grade intelligence. We're not building a landslide app, we are building climate risk intelligence middleware, translating physics into financial decisions.